right, section 4.2, workplace 20. Again here, we have a multi-step problem. This is a problem that involves three-dimensional space. This one's going to be a little tougher to draw, but this is a question. I picked this one because it does not have a diagram. And if you were asked to make a diagram, this is probably one of the tougher types. So let's go over this one right here. It says, an airplane is flying at 100 kilometers north and 185 kilometers west of an airport. So first of all, you need to know your directions, right? And I remember that since I was a little kid, never eat shredded wheat, going around clockwise there, north, east, south, and west. So I'm going to draw a diagram here where I have 100 meters or kilometers north and 185 kilometers towards the west. Okay? So an airplane is flying at this position, basically right here, and at a height of 7 kilometers above the ground. Now, right now, these lines that I've drawn are on the ground. So the airplane is above the ground. So you need to try and draw. So there's 7 kilometers above the ground. You see that? And that's 90 degrees to the ground level there. So this looks a little bit funny, and you can put this little you can put this side on an angle if you want. But what you have to realize is that here's the ground and here's the plane. And so the plane, you see, it's looking back at the airport from the air. Wow, my tablet just moved. It's looking back at the airport through the air, so it's above. Okay. Now, this right here is the line on the ground that goes straight back to the airport, you see? Okay, that's the line on the ground, the black. Now, A says, what is the straight line distance to the airport? Really, they're asking for what is the sort of horizontal distance or the ground distance, or horizontal distance. So they're actually asking for this value right here, from wherever the plane is situated to the airport. That's the distance they're looking for. Okay. So drawing these sort of three-dimensional sketches, and again, you could draw it a different way like this. You could draw it like this, and you could say, well, here's my elevation in the air, right? And this would be my 90-degree angle, and this would be, you know, the ground distance there. So you could draw it sort of on an angle like that so that it looks a little bit more three-dimensional, but as long as you sort of understand what's going on. And really important that this ground distance and the distance from the actual airplane, so here's my airplane, it's flying, okay, there we go, there's the wing, okay. This actual airplane is 7 meters above the ground, so this red line right here, the viewing distance to the airport, is definitely different from the ground distance beneath the airplane to the airport. All right, so what is the horizontal distance from the airport? Someone just tell me how we would do that. We won't take the time to do it right now, but how would I find this piece right here? Yeah. Okay, so we don't have any angles right now. We don't need any angles though. We have a right angle triangle and we have two sides of the right angle triangle. So you can use Pythagoras, absolutely. So 185 squared plus 100 squared equals this unknown side squared, and so we can find the distance using Pythagoras. So I'll just write that down here. Okay, so you should get 210.3 kilometers for this length right here. I just kind of changed that to x in our equation. Okay, 210. Everybody good with A? Have any questions about A? Good? Okay, B says, what is the angle of elevation of the airplane? The angle of elevation of the airplane from the point of view of the airport. So here's where this gets a little bit tricky, right? So what we're looking at on my original diagram, I'm looking at this angle right here between the red dotted line and the black dotted line. Let me draw this again. So there's my 7 kilometers above the ground. Here is the airport, right? Here's the plane right here. And I'm looking for the angle. Boy, that's tough to draw. The angle of elevation right here. So that's the angle of elevation right there, that little E. Okay, and now I know that this is 210.3, this length. So what trigonometric function, remembering so, ka, toa, which trigonometric function involves this angle, this side and this side. Which one is it? Sine, cosine, or tangent? Well, this is to angle E here, or angle A, whatever. This is the opposite side, and this is the adjacent side. So O and A is attached with tangent there. See that? Tangent. So that means that I can write an equation. Tan of E or A or whatever. Let's do A. Okay. Usually you name it the letter here, whatever's here at the point. So tan of A equals opposite. That's 7 over adjacent 210.3. Yeah. Make sure you put it on mute and put it away, please. Thank you. In your bag. Thanks. So this is a case where we now need to find our angle measure. Who remembers how to find an angle measure? Because we've been finding distances, these unknown lengths here. But how do you find angle measure? Do you remember what function it is in your calculator from 4.1? Anybody run into that yet? Sorry? Negative 10? Oh, negative tan. Tan. Yes, it's well, not negative tan, but it's tan to the negative 1. Yeah, it's the inverse of tan. Yeah, so if you see the second function of tan there, tan to the negative 1. Now, what you do is you simply use that function. So I'm going to go second function tan, and I'm just going to put in this fraction right here. That's 7 divided by 210.3. And then that's going to spit out the angle. Oh, except I think I am in oh, interesting. So I think, do you have to be in radians for this? No. Tan to the negative 1 of 7 divided by 210.3. Nope. Okay. So give me a second here. Okay, so yeah, we are looking, your calculator needs to be in degrees. So if it's in oh, I'm frozen again. Okay, so your calculator should be in degrees always, okay? You guys won't have to worry about radians at all. If it's in R or RAD, flip it over to degrees, okay? This is such a small number because if we look at this diagram again, you see 210 kilometers versus only 7 kilometers up. So that's a very small angle of elevation, very, very small. So the angle A is actually 1.9 degrees. Okay, 1.9 degrees. All right, so I've got the solution manual down here somewhere. Yeah, here we go. So that's a little bit neater, okay? And then there's some more diagrams there so we can see this all at once. But the second function tan, that's your tan to the negative 1, okay? That's how you find the angle. Second function tan. And 1.9 degrees is our answer, okay? So I would probably say that's going to be one of your toughest types of questions that you need to have a handle on. So if you need to go back and do some more practice from 4.2, this is a very short chapter. I think there's only 2 sections, right, in this chapter, correct? For you guys, right? So spend some time on 4.2. You've got a little bit of time before the test. So make sure you practice problems. Make sure you do some extra build your skills problems. Make sure you can get this, all right? Any questions? All right. Calculator in degrees, right on.
Do you call it tan to the negative 1?
Yeah, tan to the negative 1 or inverse tan. Yep.
Subscribe, like, comment, share.